Hello, I'm Jeremy Ellis, Canadian robotics machine learning high school teacher, and I'm going to talk about FOMO observations from the toy cars my Gearbots group has been working with. We switched from the Nano 33 BL Sense with its camera a few years ago. We just wanted a little bit more power, and the Portenta with Vision Shield right down here um, allows us to view what we're analyzing on a grayscale OLED. So first thing is FOMO, the one we're using, is grayscale. And so even if you have a camera, even if you have incredible resolution, we're working with 96px by 96 pixels in grayscale. So FOMO, the first observation is it's fast. And that is so needed for the cars. As the car gets faster, the analysis needs to be faster. So let's just have a quick look. Now notice that reflection there. That's a huge issue. So FOMO can have false positives. So the second observation is FOMO can give false positives. And in your application, can it handle false positives? So here's a counting application with the minced numbers, and it's doing okay, but if you look at it slowly, it is actually having false positives and false negatives. So here it's counting up all the zeros and the ones. It's doing an amazing job for a microcontroller. Note that that was trained on the professional Edgeimpulse 2000 training cycles. With object analysis, the third observation is when you're using FOMO, can you change a 3D object into a 2D object by having it lie flat, or any way you can get away from having to know all angles of that object? Here's something that's actually trained okay, but was really hard for us to work with. We originally
Just
had pop
got
bottles.
FOMO with Edgeimpulse working. Look how
It's going
quickly
okay, but
this analysis is
in
happening.
reality, it had too many errors. With analyzing objects, can you orient them in one direction? So a leaf that has a definite shape,
it's
can you
changing.
always analyze it with that definite shape? Lighting, reflections, huge deal for us was figuring out that reflections were causing false positives. Sunglasses seem to help briefly. Toy robot car, with our analysis with the car, we could choose what we wanted to analyze. And some things are easier to analyze, especially with the free Edgeimpulse subscription, where you're, 300 images, how many training loops, there's a bit of a problem there. Our fourth observation is if you can't control the object orientation, what about symmetry? Like, would a star, a circle, things like that be better to work with? Fifth observation is best. We found it best to detect one thing. And remember, we're going with cars that, as it works, we want them to go faster. By the way, you can go over the 10 default observations. So here's what we looked at. There's the URL for its fast Fourier transform. This is kind of what FOMO sees. And all these images have different fast Fourier transforms. And it's worth having a look at that page. Now, when we started collecting our data, we tried to use the cell phone to collect the data, taking the pictures. But it wasn't ideal. And then we tried connecting the cars, the Arduino Portenta H7, with web USB, but the cars are moving and you've got your laptop there. So what eventually worked for us was taking ping images and saving them to the SD card on the Portenta Vision Shield. I made a program. This is my Portenta Pro Community Solutions. .3 is the Vision Shield. .36 is camera pings. .362 is the one we used. We changed the speed. It was taking a picture every 10 seconds. We changed it. So for testing, you can download your model to the cell phone. You can download Wasm, and I have a link there to using WebAssembly. You could look on the OLED screen that we've hooked up to the Potenta, or realistic environment testing. So here's some fails we had
Sacrifice flies, get better
with
machine
using
learning.
pop cans. Notice those reflections there? So this was quite fun. Great that the cars were actually moving, but notice how slow it's going. We eventually had some success. One of the cool things one of my students did, first of all, he came up with these 3D printed discs that worked well. Look how fast this is going. But this student created a reverse, and he's got the lights, and we're on carpet. So that was pretty exciting. We're having some success with getting an RC backup controller. We did a lot of things with LoRa and trying Wi-Fi and things like that. So that's going well. And here's where we're at the moment. Notice the better speed. And we're using the disc. Instead of the 3D printed discs, I came up with these just photocopied double-sided discs. The colors, just I ran out of paper. So that's starting to work pretty good. It's got some speed. It's reacting to things. We're pretty happy with it. It's a single speed for the car, though. So, conclusion, Edgeimpulse Vision FOMO model is an excellent TinyML teaching environment. Lots of room for improvement with vision analysis when you consider things like number of classifications, orientation, symmetry, reducing reflections. My students and I have worked on various issues and solutions for using constrained devices with the free version of Edgeimpulse. It has a processing time limit of 20 minutes, about 300 images. And see, it's Jeremy. And I didn't want to do that.